Good morning all. This is Venkateswar Reddy Tadi, Assistant Professor in ECE Department, ECE Institute of Technology and Engineering. Today I am here to discuss about embedded systems. So now, embedded systems. So it is one of the prominent topic in the entire world. Why? Because nowadays entire world will run with or as well as that depends on only the embedded systems itself. Okay, so first of all, what is meant by embedded system? So we have to discuss that one. So embedded system, the definition. So embedded system is nothing but it is the combination of hardware and the software, and along with it is designed for a specific function. In the sense, you know about the system, right? The system is the combination of hardware and the software. So all the digital systems are about the combination of hardware as well as the software itself. But coming to the embedded systems, so that embedded system is designed for the specific application only. In the sense, whenever we are designing an embedded system, that entire lifetime of the system is only for that particular application, like washing machine, refrigerator, smart refrigerator, AC, oven, satellite, the control system in the flight. All these are under the category itself. So the definition is it is the combination of hardware and the software, and it is designed for a specific application. So it is the main difference between an ordinary digital system as well as the embedded system itself. And then applications are so many applications are there. We are having the consumer electronics are there. So like the cameras, videos, recording, everything, and household applications like the TV, DVD player, as well as the next one is the home automation, the security systems, air conditioners, and the CCTV recording and everything. So automotive industry, that telecom, and as well as so many applications entire the world. All these will be depends upon the embedded system itself. So now, what is the difference between the general purpose as well as the embedded system itself? So first of all, the system is the combination of hardware and the software, and it is for the general purpose operation. So we simply call it as a general purpose, the computer. But in embedded system, it is designed for a specific purpose, and it is the combination of hardware and the software itself. And the next one, it is contain a general purpose operating system. Like we are having a computer, the computer is having an ordinary OS, and it will run the number of applications in the desktop or the laptop itself. But coming to the embedded system, it may not contain the operating system. In the sense, if it is a small application, we write the code, it is not having the operating system. But whenever it is a large scale, compulsory we have to maintain a particular operating system itself. So it may or may not be the operating system, but in the general computing, we compulsory maintain an operating system itself. And applications are altered by the user itself. So whenever you're having a desktop, depends upon the user, they have utilized by their own. But whenever we go for the embedded system, it is designed for a specific application. Once we are loading a firmware into that particular system, that entire lifetime of the system is only for the embedded application only. So it is not altered by the user itself. And the performance is the key factor in the ordinary system. In the sense, in a general computer, whenever we are purchasing that one, so we have to concentrate on what is the efficiency of the desktop itself. But in this, application requirement is very important, whether it will be to satisfy all the requirements of the application or no. For example, we are having a air conditioner. In the air conditioner, what is the output of that, whether it is the cooling down in a specific time or not, or it consumes the low power or not. So all these the considerations will be in embedded system, but not considered in the general application. So these are some of the differences in embedded systems as well as a general purpose system itself. And history. So in the history, we don't have the specific application in the olden days, but whenever we go for the complex operations, like, so the first recognized system is about in an Apollo, the guidance system, it will be developed by MIT Instruments itself. In the sense, it is Apollo guidance system, nothing but the space mission. At that time, they implement a particular system to run entire the application. So that will be the first recognizable embedded system in the entire world, and it is designed for the MIT Instruments itself. And after that, the mass production of the system is about the Minuteman 1 and the Minuteman 2 in 1961. It is about the missile itself. So it is the next recognizable embedded system, and it is in the production itself in Minuteman 1 as well as the Minuteman 2 itself. So it is the main history of embedded system. After that, number of companies are entering into the embedded system design, and we are having the consumer electronics, refrigerators, aeroplanes, the controlling systems, and the number of embedded applications are available in the entire world. So the classification. So in the classification, first of all, we have to segregate embedded system based upon the generation itself, and the next one is the complexity and the performance itself, and the based upon the deterministic behavior of the system, as well as the based upon the triggering itself. In the triggering, even triggering is there, as well as the time the triggering. In the sense, if a particular system, whenever we have to fix the time, at that particular time it will be activated or it will be deactivated or it will be doing some certain activity. So we call it as the time triggering. But event the triggering in the sense, whenever that particular event is occurred, at that time only it will be activated or it will be activated any other system. Like for example, so we are having an embedded system in the nuclear reactor. At that time, in the nuclear reactor, we have to consider that the temperature of the nuclear reactor and the pressure of the nuclear reactor, and the next one the humidity of the nuclear reactor, and what is the condition of the nuclear reactor we have to consider. At that time, if any particular the parameter have to be changed, automatically we have to, in the sense whenever we have to increase the temperatures, we have to on the cooling system to reduce the temperature, or whether the pressure is increased or decreased, or the humidity is increased or the decreased, or the air, the density in the nuclear reactor have to be increased or the decreased. So at that time an event is occurred, so according to that event it will be operate the next attachable system itself. So either event triggering or the time triggering itself. And coming to the deterministic behavior, it will be mainly about the real-time applications itself, in the sense whenever the system depends upon the real-time data, so at that particular instant it will be react, otherwise we are having some trouble in the system itself. So that will be about deterministic behavior. For example, we are having a missile. So in the missile, we are having an hardware, the software, and it is designed for that particular application only. So whenever we release the missile, it will identify the target as well as it will be reached to the target itself in a particular position itself. So at that time, if the target is moving, okay, so whenever the target is moving, automatically whatever the missile we are having, then that will be identify the position of the target, and as well as they have to change the trajectory of the target itself. So in the sense, at that particular time, it will be react with that particular values, as well as it will be changing it trajectory itself. So it will be divided into the deterministic behavior itself. And after that is the based upon the generation and the complexity. So in the based upon the generation, the first one is the first generation embedded systems. In the sense, it is only 8-bit microprocessors only. In the sense, at the time of early days, we are having a small scale microcontrollers or the microprocessors. So the generation will be depends upon only 8-bit microprocessor itself. So it is about the first generation, and it is only about a small scale applications, in the sense digital telephony keypad or the stepper motor control are very, very small applications have to be implemented. And for the second generation, it is about 16-bit microprocessors as well as 8 or the 16-bit microcontrollers itself. In the sense, it is about the first generation is about only 8-bit microprocessors, but the second generation is about either the 16-bit microprocessor or 8 or the 16-bit microcontrollers itself. Why? Because at the time of the second generation, we are having microcontroller applications in the entire world itself. Especially for 8051 is the first microcontroller introduced into the entire world. But coming to the microprocessor, the first microprocessor is implemented is about 4004. It is about the 4-bit microprocessor, and after that 8008. It is about an 8-bit microprocessor, but these two are not the popular ones. But the popular one is about 8086 itself and 8085 also. So it is about the first popular microprocessor, and after that the 8086, and after that entire world will be concentrating on the 8051 microcontrollers itself. So in the first generation is about only 8-bit microprocessors, and for the second generation 16-bit microprocessor, or otherwise 8 or 16-bit microcontrollers itself. And for like the SCADA applications are implemented at that time, automation of the industries, the controlling of the industry appliances, or small scale consumer electronics, all these are implemented using these 8051 applications only. And after that, third generation, it is about 32-bit microprocessors itself, and 16 or 32-bit microcontrollers are implemented in the third generation itself. In the sense, it is about 32-bit microprocessor or 16 or 32-bit microcontrollers we are using in the third generation applications. In that robotic applications, media applications, and otherwise the network applications, all these are implemented in this third generation. And for the fourth generation, it is about highly scalable, highly complexable applications implemented in the fourth generation. So we go for the complex applications, in the sense more than 32-bit we are using. In that, we have to operate in the controlling of the entire industry, like industrial automation, or the controlling of the machineries, or the controlling of the airplane, or the satellites. All these complex applications will be implemented in the fourth generation itself. So all these are for the based upon generation. So classification of embedded system with generation itself. Under the complexity in terms of small scale embedded system, medium scale embedded systems, as well as the large scale embedded systems itself. In the small scale applications, only 16 or 8-bit microprocessors as well as microcontrollers also. In the sense, actually in the generation point of view, 8-bit microprocessor along with 16-bit microcontrollers we have to compare, but in this case either microprocessor or the microcontroller with 8 or 16-bit itself. So it is about the small scale applications, in the sense small scale that the toy cars or otherwise a small video, the gamers, or application of the refrigerators, ovens, all these are the small scale applications itself. In the medium scale applications, we go for the 16 or 32-bit applications. In this, we have to controlling the machineries or the sensor network in the cars itself or the network routing. All these are under the medium scale applications will be there. At that place, we go for the 16 or 32-bit microcontroller as well as microprocessor itself. And for the large scale embedded systems, again, it is more than this one. On system based applications, we are in the sense, in the large scale applications, we go for 32 or 16-bit microprocessor microcontroller in terms of the SoC designs itself. SoC in the sense, so the O should be the small. So SoC in the sense, system on chip. System on chip in the sense, system on chip itself. System on the sense, whenever we have to consider the cameras. So the size will be very small, the compact size, and as well as the capacity. Nowadays the cameras are very high compared to the olden days the cameras itself. Why? Because in the entire the digital the camera, we are having number of ICs are there and the number of applications are there, the encoders, decoders, the compressor, decompressor, all these are. Nowadays all these are available within a small IC itself. Instead of all these ICs, including all these will be implemented within a single IC that we simply called as system on chip itself. So because of uses of the number of ICs in the PCB, the size will be large, automatically it will be consumed with more power and the cost will be high, the size of the system is also very high. But whenever all the requirements are available within a small space, so it consumes very small space and it consumes very less power, automatically the size of the system will be reduced. So we simply call it as system on chip itself. So in these large scale applications, in generally we go for the SOS applications or otherwise 32 or 64-bit microcontrollers or microprocessors in terms of the risk applications only. The next one is the purpose of embedded system. So in the previous class, we have to discuss about classification of embedded systems with that particular different categories. Now we have to discuss about the purpose of embedded systems itself. In that, first one is the data collection, storage, and representation. So data, the collection in the sense, we are having some embedded systems, they have to collect the information only and they have to store the information as well as the representation of the information itself. For example, we are having a data acquisition system. So in that data acquisition system, we are having number of the sensors are there and in particular area we are having a display. That display we have to display whatever the data we collected itself, and in terms of the analysis or in terms of the graphs or otherwise in terms of the only numbers itself. So that particular system is about data collection, storage and representation. And the next one is the data, the communication. In the sense, it didn't have any memory, only it is designed for to transmit the data from one location to the another location in terms of the telecommunication or in terms of the wireless network itself. So data, the communication, in the sense they collect the data and they have to transfer the data from one device to the another device itself. And for the data processing, in the data processing, it will not store the data, it will not represent the data, but whenever the data it receives, it processes the data. Especially we call as an amplifiers. Okay, so amplifiers is about the systems only whatever the data they receive, they amplify the data and they given data to the output device itself, like encoders, decoders, the compressors, the decompressors. All these are under the category of digital signal processors. And for the monitoring in the sense, say that they collect the data and for their observe the data whether it having any parameter the changes or not. So that particular embedded systems we call as the data monitoring. And for the controlling, already we say that if any system in the nuclear reactor, whenever if any parameter is changing, automatically it will be controlling the other cooling system itself. So that particular the controlling device we call as a data the controlling itself. And the last is application specific user interface. In the sense, we are having number of embedded systems are there. In some cases, that particular embedded system or IC is designed for only that particular application itself. So application specific interface, and in the sense that interface only used for that application. Other than that, it will not be utilized in any other application. So application specific user interface. So already we know about the difference between the microprocessor and the microcontroller. The microprocessor is not having the memory inside, but the microcontroller is having the memory inside along with the IBIOS, along with the oscillators, along with the timers. But in the microprocessor, it is not having all these. It is only having the CPU. It will take the data, process the data, and it will be gives the data to the output operations. But in the microcontrollers, it takes the data, process the data. It may be stored into the internal memory or may be stored into the external memory, which will be attached. And by using the timers, the controllers, the counters will be attached inside the microcontrollers itself. So it is the main difference between microprocessor and the microcontroller. And the RISC architecture as well as the CISC architecture. Nowadays, the maximum systems are only implemented using the RISC architecture, and olden day systems are implemented with the CISC architecture. But nowadays, we have to consider ARM processors. That ARM processor is having RISC architecture. Inside it is having the CISC architectures itself. So it is advanced processing units. They have to compare all the analysis, and they have to process all the complex applications. So ARM processors are using the RISC architectures inside their operations. So the next, the core of embedded systems. In the core of embedded systems, we are having a general purpose domain, or otherwise application specific integrateds, and the programmable logic gates, as well as the commercial of the self, the components itself. So what is meant by the general purpose? Already we discussed about the microcontrollers and the microprocessors. So it is a domain specific, in the sense they are the digital ICs, and they design for either the processing applications as well as the processing, including with the controlling with the digital input and the digital output data only. So the microprocessor and microcontroller is about domain specific as well as the general purpose itself. In that, we are having another one we called as a digital signal processing application. In the digital signal processing applications, so whenever we are having an audio signal is there, or we are having an image is there, so in these two applications will not be run by the microprocessor as well as the microcontroller. Why? Because whenever we are processing audio signal image processing applications, number of the filters are available, but if you are try to implement in these two, it will be created the complexity. So whenever we go for the digital processing applications, already all those filters are internally designed. So we can easily evaluate what is the strength of the signal, what is the requirement of the signal to implement for the further actions. So these type of applications will be implemented using digital signal processing applications. And the next one, application specific integrated circuits. So application specific integrated circuits. In this, the IC is designed, or the processor or the controller is designed for only that particular specific application. Especially we are having a mouse, optical mouse is there. So in the optical mouse, we are having an IC. That IC is having a small window to receive what is the optical light we are moving in the surface of the desktop itself. So that IC is designed for operation of that particular optical mouse only. So application specific integrated circuit, in the sense that IC is only for that particular application, and it is not used for any other applications itself. And the next one is the programmable logic devices. We call it as PLDs. In generally, the PLDs are used in our research and development operations. Whenever we are trying to design a particular embedded system, at that time we have to design a processor or a controller. So at that time we don't know about which processor we are using or which controller we are using in that. So at that time we go for the PLDs. In that we have to create our own logic to implement a particular IC, and we verify whether it is working or not. If it is working properly, then we go for the IC design, or otherwise redesign the entire system. So the PLDs are using the further R&D purpose itself. And the next one, commercially of the self, the components. In the sense, observe these components. All these components are already manufactured, and these designs are a particular application. It is about actually a motor driver, and it is about a LAN the converter. In the sense, LAN to the DB9. It is about the LAN, and it is about the DB9 the connector. So the converting of the LAN connection to the DB9 connector, and it is about the same information will be reflected here itself. So already these modules are designed. We simply purchase that one, and we are included into their embedded applications, and a small code is need to run these devices. So we simply call it commercially off the shelf components itself. So all these are the core of the embedded systems. And the memory. So the memory is the main part of an embedded system. Why? Because whenever we are doing any particular operation in embedded systems, we are having a code, or we are having firmware, or we simply call it as an operating system also. Okay. So in these two, we have to load into the memory of that particular device itself. So without that, we can't do anything. Why? Because in general embedded systems or the specific embedded systems are general purpose, the computing, we want a code or operating system to run the entire system. So either the code or the firmware or operating system, we have to load into the memory only. So the memory is the main part of entire the embedded system itself. And we are having a different categories in embedded systems. The first one is the on-chip memory, and then the second one is the off-chip memory itself. On-chip memory, in the sense, inside of the embedded system or IC, we are having a small part of memory. We simply call it as on-chip memory itself. And off-chip, in the sense, externally we have to attach to the memory whatever the memory we required. So off-chip memory. So these two plays an important role in our embedded system applications. If the system is very small, they have to do any minimal applications. At that time, we go for the on-chip memory itself, or otherwise it is having an operating system, or the number of the files you have to load it, or number of applications you have to load it. So internal memory is not enough. At that time, we go for the off-chip memory itself. So in that, first one is the ROM, and the next one is the flash memory, and RAM also we are having, we call it as the NVRAM, non-volatile RAM itself. And in the category of ROM, we are having a PROM is there, master ROM is there, EPROM is there, EEPROM is there. In the sense, programmable ROM, master ROM in the sense, at the time of the manufacturing only we have to load the program, otherwise it can't be load any other programs. And electrically erasable, the programmable ROM is there, and electrical erasable ROM is there. Okay, so all these are the different categories in the memory called as a ROM and the RAM applications. But ROM is the fixed memory. Once we store the data into the system, that will be available. But RAM, whenever we switch off the system, the data in the RAM will be vanished, and we call as a non-volatile memory itself. And the second one is the volatile memory itself. But ROM is for the storing purpose, and the RAM is for the only system operation. In the sense, whenever we are purchasing any digital system like a mobile or the laptop or any other embedded systems, we are verifying what is the size of the RAM itself. Why? Because if you're having a ROM is only for storing our data, whatever the data is there, or operating system or the firmware. Once we store that one, that will be available into the memory. So how much amount of the ROM is needed, we have to decide. But RAM is not for the storing of your regular data. So what is the RAM? Whenever we are running a system, whatever the system is there, whenever we are running that one, at that time, whatever the instructions available into the memory, that will be transferred to the RAM itself, and in the RAM it will be executed. In the sense, if the RAM is small size, so number of instructions per cycle is less for the execution, and if the RAM size is more, so number of instructions are loaded into the RAM is more, so at a time more number of instructions are executed, automatically that will speed up the system operation. So for that reason, we are having high amount of the RAM compared to the ROM itself. So the ROM purpose is entirely different and the RAM purpose is entirely different, but speed of the system is depends upon the how much amount of the RAM we are having into the system itself. And already we discussed about the different types of the ROMs, the masked ROM, programmable ROM, erasable, electrical erasable, flash memories, and non-volatile RAM itself. Non-volatile RAM in the sense, actually RAM we call as a volatile memory. Whenever the power is off in the system, automatically the data available in the RAM will be vanished. But non-volatile RAM, the data will not be vanished itself. So we call it as a non-volatile RAM itself. And the different types of the RAMs are nothing but static RAM, dynamic RAM. So static RAM and the dynamic RAM both plays a major role in the system applications. So first of all, static RAM. So what is meant by the static RAM? It will be made up of the flip-flops first of all, and it will be stored the data in terms of the voltage. It is very important. So SRAMs are working with the flip-flops in the sense, whenever we are implementing a static RAM, that will be implemented using the flip-flops and the store the data in terms of the voltage only. So the static RAMs are the form of the RAM applications, and realized by using 6 transistors itself. Okay, and for the coming to the dynamic RAM, it is quite opposite to the SRAMs itself. So it will be stored in terms of the charges. In the sense, the dynamic RAM have to be stored the data in terms of charge only. But the problem is, whenever we store the data in terms of the charge, whenever the time is the pass on, automatically the charge will be discharging. In the sense, if the system is not working and the system is in ideal mode, automatically the charge will be discharged slowly, and after the certain time, entire the memory in the RAM will be vanished itself. So for that purpose, we go for the other option we call as a refresh circuitry have to maintain. In the sense, periodically we have to refresh the circuit to maintain whatever the charge inside that one, that will lead to the certain amount of the memory will be available into the RAM itself. So we call it as a dynamic RAM. So in the dynamic RAM, it will be working with charge, and because of that, the discharging property of the charged particles, we have to maintain a refresh the circuitry inside that one. So it is the difference between the dynamic RAM as well as the static RAM. But in the static RAM, we don't need about the refresh the circuit. Why? Because it will be working with the voltage. Sensors. The sensors is the main operation in the embedded systems. Why? Because whenever we go for any particular embedded system, for example, we are having an AC. AC in the sense air conditioner. What is the operation of the air conditioner? It is having a compressor, and we are having a blower, and we are having a temperature, the sensor itself. Okay, so whenever we are on the system, the temperature, the sensor have to be read the room, the temperature itself. In the sense, what is the present existent the temperature in the room, it will be recorded by the temperature sensor, and that information will be connected to the whatever the controller available in the system itself. And in the system, we feed a temperature, let it be considered a 20 degree centigrade or the 24 degree centigrade, and whatever the temperature we read or we record, that will be compared with our user defined value. If it is less or the greater or equal to will be identified. If it is not equal or the less than that one, automatically they have to on the compressor and they have to on the blower of the AC itself. And so the compressor will be on as well as the blower will be on, and they try to reduce the temperature is equal to 24 or the less than the 24 itself. In the sense, whenever the temperature will be recorded by the sensor, at that time only it will be identified, and they have to on the compressor, they have to on the blower. So it is the importance of the sensor in our embedded system application. So the sensors are having a different, the types are available. They're having a temperature sensor, motion sensors, light sensors, proximity sensors, pressure sensors, humidity sensors, and the gas, the sensors also. Each and everyone is having its own property, but what is meant by the sensor is nothing but they have to identify the physical quantity, that the physical quantity will be converted into the electrical measurement unit itself, and that electrical measurement value will be transferred to the processor of the controller, and in that we have to process as per our requirement itself. So like a transducer, the sensor is nothing but a transducer, simply converting a physical quantity into the electrical the quantity itself. And depends upon our application, we have to utilize in terms of a different applications itself. And next one, actuators. So actuators are nothing but, there are nothing but a transducer, but whatever the electrical the signal is there, that will be converted to the mechanical motion. It will be in the linear motion, or maybe it will be in the circular motion itself. So a different sensors like different actuators also available in terms of a DC motor, AC motor, the servo motors, and the geared motors, as well as linear electric actuators also. So it is about the linear motion, remaining all are about the circular motions are there. So we completely called as actuators. What is the purpose of actuators and the sensors itself? So observe this slide. So we are having a system. First of all, in the system, first we are having the sensor unit. That sensor unit have to be record whatever the parameters we have to observe, and from that they have to utilize an information, the transfer. So like any network router or the wireless device or the wired device, we have to transfer the data. In the controlling system, they have to identify and they analyze, and based upon the firmware exists in the system, they have to identify what is the parameters are related to which the component. So they have to decide, and according to that they have to maintain the operation of actuators itself. For example, we are having a water tank, the controlling unit. In the water tank, the controlling unit, we are having a water tank here, and we are having a number of levels are there, and inside that we are having the sensors are we are locating, and that information will be attached to the a controlling unit. And in the controlling unit, we have to identify what is the level of the tank itself, and by using that we have to be on or off the whatever the motor we are having, that one we call as a pump, and it is about the relay. So from the pump we have to load water into this water tank itself. In the sense, the sensor will be record whatever the measuring values of the water level, and that information will be controlled by the control unit. In that control unit, they have to identify it, and according to that, they have to on the motor with some relays itself. And whenever the motor is on, automatically water tank will be filled. Again, the sensor will be identify the data and given to the controller. Once the water tank is filled, automatically the control will be off the motor with the required data operation. So it is the combination of sensors and actuators in our embedded applications. Thank you.